Okay, so in this case, we're going to go over the Ivy in case your internet was bad or you missed on the Zoom meeting. So this is Ivy's growth, the task. So you're a medical assistant in a pediatrics office, and Ivy Smith is your person. And when she came in at 3 months old, you found that her inches were 21.5. She was 21.5 inches long. Then again, at 8 months old, her inches were 24 inches. So assuming Ivy grows linear, so we're making this huge assumption that Ivy is going to grow linear. This says that we're going to go, this is your inches and this is your months. So basically, this is your X, this is your Y. So what we have to do, so in this case, we have to figure out our first point, 21 inches, 3 months. Well, months is first, and then that's 21.5. And then for our next point, so for that next point, 8 months later, or 8 months when she's 8 months old, 5 months later, she is 24 inches. So now we have to find that slope. And when we go through and we find that slope, remember that it's y2 minus y1, x2 minus x1. That's slope formula. So we're going to take 24 minus 21.5. And then I'm going to take 8 minus 3. And I go through 24 minus 21.5 gives me 2.5. So 24 minus 21.5 is 2.5. And then 8 minus 3 is 5. And then I go through and I work this out. And 2.5 divided by 5 is 0.5. Okay, so now we found our slope. So now we know that y is equal to 0.5x plus b. We've got to find that y-intercept. And in order to find, and that's going to be when at 0 months. How many months is she at 0 months? So we have this, we have our slope, and we've got y equals mx plus b. So y is equal to mx plus b. And that's what we're looking for, is that y-intercept. So in order to do this, this is my months, MO for months, that's x. And this is my length in inches, that's y. So at 0 months, I don't know. At 1 month, I don't know. At 2 months, I don't know. At 3 months, I found this to be 21.5. And then at 4 months, 5 months, 6 months, 7, and 8 months. So if I just kind of go through and do this, and then I got this to be, so we got this to be every time we added 0.5 inches. So I'm adding 0.5. So 21.5 plus 0.5 is 22 inches. 22 plus 0.5. So as I go down my list right here, I'm adding 0.5 because that was my slope. So 22 plus 0.5 is 22.5. And I keep adding 0.5. So then this would be 23. 23 plus 0.5, 23.5 because I added 0.5. And then 24. Hey, that worked out because at month 8, I got 24 inches. So that worked out perfectly. The problem that I'm having trouble with and that I have to do is that we have to work, and I need this amount right here because that number right here that's missing is my B, is that y-intercept. That's my B. So instead of adding 0.5, I'm going to have to go here and I'm going to subtract 0.5. So 20.5 minus 0.5 is 21. 21 minus 0.5 is 20.5. 20.5 minus 0.5 is 20. So this y-intercept is 20. Now this is called the model. So whenever, and that's like saying the equation. And this is a model because we made that assumption that Ivy is going to grow linearly. So she's going to grow in a linear pattern, her growth. And so her height is just going to keep continuing to grow at a steady rate. And we know that's not necessarily true, but we're making that assumption to make our life a little easier and give us predictions. So you're going to use your model, your equation, to determine how much she is in inches. Go to inches into centimeters. So we have to know that she is 20 inches at birth. So she's 20 inches at birth, and then we know to figure that out. But we know from up here that it says that she is, for every 1 inch, there's going to be 2.54 centimeters. For every 1 inch, there's 2.54. So we're going to take that 20 and we're going to multiply it by 2.54. And then when we go through and we do that, we get 50 centimeters, 50.8 centimeters. So 20 times 2.54, you type this into the calculator. I don't know, you have to do that. And then that's how much she is. So then you use your model. Again, your model is your equation to figure out how tall she'll be at 1 year. Well, when we do this, so we have to do 1 year. You have to know how many months that is. And then you're going to do this again for 3 years. How many months is that? So those are things that you have to know. So in 1 year, she is going to be, so I'm going to take my equation because I have my length. Her length is going to be 0.5 times however many months plus 20. Again, my equation, y equals 0.5 times however many months that is plus how much she was at birth. So in that months, in order to do for that particular month, so 12 months, 1 year is 12 months because there's 12 months in a year. So 12 times 1 is 12. So I'm putting that in. 0.5 times 12, because we're doing PEMDAS, 0.5 times 12, multiplication comes first, 6 months plus 20, so that's 26 inches. In 1 year, which is 12 months old, she's going to be about 26 inches. So the next one, in 3 years, so 3 times 12, so 1 year is 12 months, 2 years is 24, 3 years is 36 months. So 0.5 times 36 ends up being 18. So 18 plus 20 gives me 38 inches. And in 3 years, that's about her length. So the next thing says, okay, we're going to use our model. We're going to go through and do the same thing, except now we're going to use our model to estimate. So remember, your model is your equation to estimate how old she's going to be in years and months when she measures 48 inches. So 48 inches, that's why we need to figure out X. That's what we don't know. So we have to figure out X. So I know that 48 inches goes here. I have 0.5 X, I don't know what X is, plus 20. So I'm using my model, my equation, and the only thing I did was substitute in 48 inches in. And then I'm going to do this over here so you can see, and I'm going to use PEMDAS. I'm going to use that PEMDAS rule. So PEMDAS, if X was a number, so we think about what we did up here when X was a number, when X was like 12. We're just going to use this as an example. So if this was 12, I have X. So then that thing was I multiplied by 0.5 first. I multiplied by first, then I added 20. That's when X is a number. But we're working backwards. So when we have to work backwards, we have to go through and we're going to take, and when we go backwards, so the opposite of add 20 is going to be subtract 20 because you're going to work from the bottom up to undo. So now we have to undo. So now we're working from the bottom up So that goes away. 20 minus 20 is nothing. So 48 minus 20 ends up being 28 equals 0.5x. And I ran out of room, so I'm just going to rewrite this. 28 equals 0.5x. So that next step says, okay, so I added 20. The opposite was subtract. Now, instead of multiplying by 0.5, I am going to do the opposite of multiply, which is divide. Divide by 0.5 on both sides of the equal sign. And then 0.5 divided by 0.5 is 1. So I get x equals 28 divided by 0.5. 28, and then, you know what, guys? We're just going to use the calculator. Why? You're going to take your calculator and you're going to go 28, divide by 0.5, and we end up getting 56. That's a 56 total months, but nobody measures in months like that. And after about 2 years old, we stop measuring in months. When you're 24 months old, then we start calling you 2, 3, 4, 5, 6. So we've got to go because that's like 56 is more than 24 months. So we're going to go 56 and divide it by 12. So 56 divided by 12. And I get 4.6 repeating. And okay, so now I know that that's 4 years. But then how many months is that? Because that's what that's asking. They're asking you to find this because that's what the question is asking, in years and months. So we got that 4 years. Okay, we got that 4 years. So I'm going to subtract 4. And now I'm left with that 0.6 repeating. And I'm going to take that and I'm going to multiply by 12. So that gives us 4 years and 8 months. So Ivy, when she is using our prediction, our model, when she is 4 years and 8 months old, she is going to be 48 inches tall. Because by this time, hopefully by 4, she can stand and walk. All right, so now we're going to measure in height. Okay, so using your chart, so you have a chart. I don't know where my extra chart went. So we're going to use the one I went over in Zoom. So you're going to use your chart. This is your chart that you get. This should be in your binder. You're going to use this chart, and we're going to actually look at this. And we're going to use those things. So we have birth. Okay, we're going to have 12 months. We're going to do that comparison. And then we're going to look at 12 months. And do I have 36 months? Yeah, we have 36 months. And then we have 36 months. And we're going to look at the comparison on the chart versus what she is. So at birth, this is a girl chart. So up here, this is going to be your length. So this is how tall they are. Down below is going to be their weight. So there's a weight and there's a length. And these are all, honestly, these are like what they actually use when you go in. And is this really a linear model? Is that really a good fit? So I'm going to look, and I'm going to look at birth. So at birth. And this part right here is my inches. So this part is my inches. So I'm going to find 20 inches. And then I just go straight across and I put a line there. And then I'm going to highlight the line that goes to. So this is my highlighted. I highlighted it earlier in the Zoom call. That is going to be green. So I just highlight that line. So at 20, okay, that was good. So this is where she was given. So at 20, she's at 20 inches at birth. Using my chart, so at 12 months, using that chart. So at 12 months, this is right here at 12, that's my months, I'm going to go straight down my chart, and then I'm going to hit my line, and then I'm going to go over across, and I'm estimating that she is going to be 30 inches. So at 12 months, using the chart, she would be 30 inches. And if we looked right there, she's 20. Our prediction using the equation was 26 inches. The chart says that she is 30 inches. Yeah, it's a little off. But if you notice, this equation that we used right here is going to be linear. This, however, is not linear. So if we go to 36, and I go to my line, and then I got to go all the way over. Well, actually, it gives me my length this way too. So it looks to be like she's about, we're just going to make an estimate, that she's about 38 inches. So this is about 38 inches. So, whoops, sorry. So this is about, using my chart, she's about 38 inches. When I go up here, oh, well, that linear model worked out pretty good because we got that she was 38 inches. So at 12 months, it's not a good model, but about 36, it kind of is. So, that worked out pretty nice. So what happens, and then this very last question on here is talking about percentile, and it's really hard to see, but this part right here that's highlighted in yellow is the percentiles. And so I rewrote those right here, percentiles. This top number right there is 97. This number right here is 90. This number right here that she's at is 75, because that's my green line that went over 75. And then this one is 50. This is 25. This is 10. This is 3. That bottom number is 3. And I just rewrote those numbers right there because it was really hard to read. So what happens with your percentiles is that this means that if you're in the 97th percentile, only 3% more, 3% of the population at that age of a female is going to be taller than Ivy, if that is it. But Ivy's in the 75th percentile. So that means that 25% of the population is going to be taller than Ivy or not. And 75, so she's in that 75%. This would be smack dab in the middle, 50% of her blood, 50% of. So she's at 25% above, are going to be taller than her, and 75% are going to be shorter than her. So that's kind of where she's at. So this is that. This would be 75th percentile. Okay, your assignment is to go through and to do the Anton. This was 75th percentile. I knew you guys were in class. You would totally tell me you didn't see. So this is your assignment, and this is what you're going to do is that Anton exit